Hello, this is Asbestos in New York City, a comprehensive analysis of the 5 boroughs. We are Team 6, Anna, Eric, Alex, Sari, and David. So background, we pretty much got this data. It's on asbestos and asbestos treatment in New York City. Asbestos is a naturally occurring material, but it's highly toxic. Pretty much in like the 20th century, like around the 70s, a lot of companies were using it because it was fireproof. And it was really good preventative for that. So a lot of the buildings built in that time period used it, except they didn't know that it was actually really poisonous for you. So we got our data from New York City Open Data in the environmental section. This data is actually updated monthly, and it's from the years 2018 to 2019. So the data set that we had was pretty large. It's 35 columns, around 39,000 rows. There's so many subsections in the data. Our biggest issue was cleaning the data because there was significant overlap and a bunch of unnecessary data. Also, we had to deal with 2 different units, linear and square footage. So for the duration of this project, we sort of just eliminated linear square footage. But as you can see in this picture, these are some of the issues that we had to come across, where if we wanted to use the word basement, there was several different ways that people inputted the data. It's like spelt incorrectly but meaning the same thing. So we pretty much used our deductive reasoning to put all this data into different buckets and figure out categories from there. So this is a lot of data that we had to go through.
Thank you, Alex. We had 2 types of problems here. We had a problem that we wanted to answer about what was going on in New York City regarding asbestos. So we used descriptive statistics and descriptive analysis of the situation to get a better grasp on that. And we asked the specific hypothesis, or we asked the question, does treatment time increase with asbestos amount, and tested that hypothesis with a regression. We used 2 specific measures for approaching the problem. We used the amount of asbestos measured in square feet, and we used a measure that we calculated by taking the start date and end date of the projects to give us our second measure, which was the length of the project. As you can see here, we have descriptive statistics on those 2 measures. We have the length of the project and the amount of asbestos. On average, the length of these projects was around 335 days, so about a year. The average amount of asbestos was about 605 square feet of asbestos, but as you can see in the standard deviation of 2,113 square feet of asbestos, there was a lot of variance in the amount of asbestos in the 32,651 cases of asbestos. And if you take a look at the sums of the lengths of the project and the amount of asbestos, you can see the total amount of time measured in days and the total amount of asbestos measured in square feet in this data. And we came across a difficult task in that Alex hinted at earlier with the basement buckets. We had a lot of data that needed to be put into various buckets, and we had to determine which buckets would be the best buckets. And so to do that, we used this approach where we took a sample of random line items from the data and used Microsoft Word to create a word cloud to show us the most common words in the type of treatment for the asbestos, so that we can determine the best buckets to bucket them in, such as piping, caulking, window, tar, vat, floor, etc.
Thank you, David. So after the previous slide, we tried to figure out where exactly it is that the asbestos treatments were taking place and in what kind of facility they were taking place. So here you can see that in Brooklyn and Manhattan, the residents were taking up, residence facilities were the ones that were taking up the most asbestos treatments. And in addition to that, in Manhattan, commercial was also a big contributor to asbestos treatments in New York City. Here we can see a heat map that we created. So in the top left, it's New York City asbestos for the years of 2018 and 19. So that's all the data compiled together in Tableau. And from there, we can see that in the Upper West Side had the highest concentration of asbestos treatment by square footage. So we also wanted to see who or what type of facilities were contributing to that. So in the bottom, you could see that the residences and the schools in the Upper West Side had the highest amount of asbestos by square feet in the borough of Manhattan and New York City. So this chart actually shows the asbestos distribution by floor location. So all the floors that we have here, roof, high floors, first, second floor, basement, these are pretty much the buckets that we had to create, the ones that we mentioned before. So the multi-level would include works that were done that include second, third, fourth floor, etc. Everything outside would include things on the sidewalk or things on the street, just things that are pretty much we had to put into a bucket. So here we can see that the roof was the main contributor of all asbestos treatments in New York City over the past 2 years. This map would pretty much show the distribution of asbestos by amount in square footage over the various zip codes in New York City. So for example, you could see the very first red, the zip code, there's a zip code in front of me where it says that the residents in what appears to be Brooklyn, in that zip code, asbestos treatments were very high by residents in that zip code. From there, we wanted to see what the average amount of asbestos was per building. So this includes the data from the entire data set. So the blue one is linear and the orange one is square footage. So this is just the average amount of asbestos by building in New York City.
Thanks, Alex. We decided to run a regression to test our hypothesis on whether the amount of asbestos can be used as a predictor in the amount of time it takes on these projects. And as you can see here, by the very low R squared and adjusted R squared, the fit of the model here is horrible. The p-value is very high, therefore we do not reject the null hypothesis and conclude that the amount of asbestos does not affect the length of the project. So in other words, no matter how much asbestos you have, it's going to take about a year to fix it. They allocate about a year whether you have 50,000 square feet of asbestos or 10,000 square feet of asbestos.
So finally, here we can see the potential uses of our data and the limitations from the work that we have done. Thank you.